I'm R. Kishore Kanna from Department of Biomedical Engineering from School of Bioengineering, BIST, Bharat Institute of Higher Education and Research. I am here to give lecture on 8086 architecture from course name called Microprocessor and Microcontroller in Biomedical Application. Before going into the 8086 architecture and its working process methodology, I want to reveal what is the relationship between microprocessor and microcontroller and biomedical engineering. So, biomedical engineering means conveying or providing the healthcare demands with engineering aspects or engineering emerging ideas is known as biomedical engineering. So microprocessor and microcontroller is being used widely to construct a medical instrument or a medical equipment which is being used in healthcare industries. So microprocessor means a processor or a processing unit which picks up the input, process it in microseconds and provides the output. Okay, it is being providing the output in microseconds, so it is being declared as microprocessor. Microcontroller means a component or a equipment which is being controlling the function of microprocessor is called as microcontroller. So microcontroller will be called as a controlling element or a controlling unit which will be controlling the function of microprocessor. Microprocessor will be processing the elements to provide the output in microseconds. So microprocessor and microcontroller will be acting as or will be declared to be the basic structure of healthcare devices. So microprocessor and microcontroller is being widely used in biomedical application and biomedical field. Okay, and we are going to see about the 8086 architecture. 8086 architecture is the basic microprocessor component in biomedical applications. Before 8086, it was 8085. 8085 was the first microprocessor which is being proposed by the Intel company, which is being declared as a microprocessor, which is being doing the same process in 8-bit. 8086 is the advancement of 8085. 8085 was being having some cons and pros. Over the pros, cons was being quite larger. To avoid the cons of the 8085, 8086 is being invented as the advancement. 8086 introduction. It is a 16-bit microprocessor. 8085 was the 8-bit, but this one is 16-bit microprocessor. 16-bit means it will be having 16-bit data bus. Okay, data bus means a bus which will be processing the given input data with 16 memory lines. That is known as 16-bit data bus, and it will be having 20-bit address bus. 20-bit address bus is quite large. When it is being having a large address bus, it is being used for fast processing to store the processed given input data in the location. So 20-bit address bus will be acting as a unique property of 8086 for the fast processing. Then it will be having its memory up to 1 MB. 1 MB of memory can be used at same time. It is another unique property which is being declaring the 8086 as the fast processing microprocessor, and it will be having several flags for several processing units. Okay, processing will be acting as a arithmetic processing like addition, subtraction, multiplication, division, decimal operations. Every flag will be having or assigned with several processing units. In 8086 there are 9 flags: carry flag, parity flag, sign flag, zero auxiliary flag, direction flag, trap flag, interrupt flag, and overflow flag. These are the 9 vital flags which is used in 8086 for fast processing of the given input data to produce the output data in microseconds. It can be operated in one of the minimum mode or maximum mode. In minimum mode, given input data will be verified and allocated for the processing of the unit. In maximum mode, it will be using the actual function of flags to produce the output. This is the variation between minimum mode and maximum mode of 8086 microprocessor in biomedical applications. And it has a pipelining for its supporting characters. Pipelining is being used to transfer the data from one point to another point. If more pipelining is being aligned in the architecture or structure of a microprocessor, it will be helping for the fast processing of the microprocessor, and supports some integer, decimal, arithmetic operation, which will be quite complex for 8085, which was the previous version of microprocessor. For 8086, it is an easy task for performing the arithmetic decimal integer supporting processing unit, and it supports the instruction. An instruction is a command which will be provided to the microprocessor from the microcontroller. The supported command or supported instruction which will be communicating to process some arithmetic function like multiplication and division operation. It operates on frequency. 8086 will be operating in the frequency range of 5 to 10 MHz, and the memory space will be allocated and will be segmented according to the data which is being processed and to produce the output. So 8086 will be having a large memory, 8086 will be having a large pipelining, and 8086 having a specific flags for performing this operation according to the need and demands of the given input. These are the introduction of 8086, why it is been happening advancement of 8085. And now we are going to see about the features of 8086, why it is being considered as the advancement of 8085, or why it is being declared as the fastest microprocessor when it is being compared with 8085. First point, it has 16-bit microprocessor. It is a 16-bit microprocessor which is double the amount of 8085. Why? Because 8085 was the 8-bit microprocessor. 16-bit microprocessor is quite powerful for processing the given input data to produce the output data within specific micro time period. It is quite powerful and it has the ability to deliver the output within that certain time. And 8086 has a 20-bit address. I already told it has a 20-bit address, and main thing, it has 1 MB of memory location. So when the input, a large input data sequence is being taken as an input and it is being processed at same time. Okay, it is not processed at different phase or different timing periods. It is being a large input data which is acquired will be processed at the same time, and it will be segmented allocated to a memory at the same time. Why? Because it has 20-bit address bus and it can access up to 1 MB of memory location. This makes the microprocessor to be advanced material when it is being compared with its previous generation, and it can support up to 64K or kilobyte of input and output ports, where the large amount of input sequence can be acquired and large amount of output can be processed at short time period. This is the ultimate aim of 8086 microprocessor, and it has the ability to provide 14 to 16-bit register, and its word size when the input data is being given and it is being processed and it is being declared as output in a command means it will be providing in word size which is being 16-bit, and it is being having a data bus. Data bus means a data which is being transferred from one block to another block will be carried through the data bus, that is known as data bus. Address bus means when a processed data will be allocated with segmented of address and it will be carried from one point to another point, that is known as address data bus. So address data bus and address data bus will be allocated from AD0 pin to AD15, and special function address pin will be A16 to A19 in 8086 pin configuration structure, and it requires single phase clock. It requires single phase clock means it has a unique timer which will be providing a timing command for the 8086 to produce the output within that certain time period, and it has 33% of duty cycle to provide internal timing. This is the property of 8086. 33% of duty cycle, a cycle which is to be repeated to acquire the great input and produce the output within microseconds, is the ultimate aim and ultimate functioning of 8086 microprocessor. In that function, in it has the 33% of duty cycle for providing internal timing work of 8086 microprocessor, and this is known as the features of 8086 microprocessor to be considered as the advanced microprocessor when it has been compared with its previous generation. And now we are going to see about the properties of 8086 microprocessor. 8086 has been designed to operate in two modes. I already told it has two modes, minimum mode and maximum mode. In minimum mode, it will be making ready of the data by aligning, and for the processing it will be getting ready in minimum mode. In maximum mode, processed data will be analyzed to produce the output. So it will be designed to operate in two working modes. One is minimum mode and another one is maximum mode. It can prefer, and it can be fetching its instruction byte, a instruction or a command which is being given from microcontroller to the microprocessor. For functioning of microprocessor is considered as the instruction. From memory, instruction will be given for aligning, for increasing the speed of the processing, for executing the output as the instruction will be given to the microprocessor. And for working of this 8086, it requires some power supply. The specification of power supply will be plus 5 volt. It will be having 40 pins. Okay, one side will be allocated with 20 pins and another side will be allocated with 20 pins. So it will be considered as a 40 pin in dual line package, and its address will be ranging from 00000H to FFFH. According to this address range only, address will be segmented, address will be allocated, the processed data will be stored in that address, and that from the address it will be acquired to produce the output, and according to the instruction only, this data will be allocated, segmented and picked up in the 8086 properties. Memory in byte addressable, every byte has separate address. I already told a data which is being processed by the 8086 microprocessor will be segmented. Each data will be segmented into each address. It doesn't have a combined, or it doesn't have a correlate addressing where multiple data is being stored in a single address. For each data, each address will be aligned for making the process to be fast and quick. That is the these are the 8086 unique properties, and this is the architecture, internal architecture of 8086. We will be considering this as an internal block diagram of 8086. Starting from, okay, I will be explaining you what are the components which is being located in architecture of 8086. And top you can see the memory interface. Memory interface means it will be considered to be a storage area where the processed or data which is being yet to process, or which is being processed to produce the output, everything will be stored as a data or a component in memory interface, which is known as storage area. The architecture of 8086 is being classified into two phases. Okay, BIU and EU. BIU means bus interface unit. EU means execution unit. So architecture of 8086 is being classified into two types or two units, which is known as BIU unit and EU unit. BIU unit means bus interface unit and EU unit means execution unit. Bus interface unit will be considered as the input unit. EU execution unit will be considered as the output unit. So when you are taking the input to a microprocessor is being picking input, it will be picking in the instruction wise in the it will be allocated and it will be picking according to the lineup. So the instruction or a data which is yet to be picked up by a microprocessor will be given in the queue format, and it will be given to the address bus or a data bus. Data bus will be acquiring and it will be processing according to the control of the control system. Here control system will be working as a controller which will be controlling the function of the microprocessor, internal function of the microprocessor. So according to the commands of the control system, the instruction which is being picked up as the input will be processed and it will be given to the data bus and address bus. After it is being processed, it will be given to the special function register called ES, CS, SS, DS and IP. In next configuration topics, you will be studying what is ES, what is CS, what is SS, what is DS and what is IP. And it will be given to the arithmetic operation function where the unit will be composed with flags, that 9 types of flags. According to the given input, that flags will be induced and it will be processing, and according to the flags operation, the given input data will be processed, again it will be given to the control system. After the data is being processed in bus interface unit, it will be given to the execution unit. Here in execution unit, they will be using ALU, CPU, operands and flags, and special register for aligning, for processing, for analyzing, and to deliver the output within microseconds. After the bus interface units function, after the processing of the given data, it will be given to the execution unit. Execution unit will be having function register, special function register. Okay, AHBH, CHDH, ALBL, CLDL are the register. SPBP, SIDA are the special function register. According to the working condition of this registers, processed data will be aligned and it will be stored in the address and it will be stored in the memory location of 1 MB. I said already in the properties of 8086. After it is being stored in the memory, it will be retrieved or it will be sent to the ALU, which is known as arithmetic logic unit. According to this logical checking of arithmetic operation is known as arithmetic logic unit. This unit verify whether the unit or whether the data which is being processed by the BIU and EU special register is being logical or it has been having any error will be determined by this ALU called arithmetic logic unit. After it is being verified, if any error has been occurred due to the speed or due to the time requirement, some error can happen. Okay, when sometimes error is been happening rarely, it will be verified by using the operands and flags. Mostly it won't be happening. Sometimes it can happen due to the time requirement and fast processing of the processing nature of the 8086. If it is there, it will be verified by the flags and operands. After verifying of the ALU flags and operands, it will be given as the output. Output will be generated. This whole process will be acting in microseconds. That is the unique character and ultimate aim of the 8086. Process happening in BIU, process happening in EU. Bus interface unit and execution unit will be happening within microseconds. The given input data will be processed and will be produced by these processing elements in microseconds. That is the architecture of 8086 microprocessor. Okay, I already told you there will be two blocks in internal architecture of 8086. One is BIU and EU. BIU means bus interface unit and EU means execution unit. BIU will be handling with all transaction of data, a data which has been picked up, a data which has been yet to be processed, the data which has been processed, and data which has been segmented in the address before it is being given to the EU will be processed in BIU. EU will be aligning the address according to the processed data, and it will be executing the instruction from the instruction system called control system according to the byte. It will be aligned with the queue format, and BIU will be performing the all bus operation in bus interface unit, such as reading, writing, fetching, processing operands by using the flags. And now we are going to see what is the relationship of microprocessor in embedded biomedical application. I already told in starting of this video itself, all healthcare industry which is being served by the biomedical engineering is being developed by the electronic gadgets or electronic equipments. That electronic equipments is being composed or constructed by using this microprocessor and microcontroller. So this microprocessor and microcontroller will be considered as a basic structure to develop a healthcare device, instrument, and etc. What are the gadgets which is being served or which is being produced in the biomedical aspects or biomedical domain will be developed and constructed by using this microprocessor and microcontroller only. And we want to have a system that which is reliable. Microprocessor has been very reliable, and we want to construct medical equipment which should be in smaller in size, and it should be lightweight to be portable. Why? Because equipment should be used in healthcare domain frequently. Equipment which is being used in ICU will be also used in operation theater. Equipment which is being used in ICU which can be also used in ward. For example, ECG machine, EEG machine, EMG machine. Then, for example, pacemakers which is being used in the OT can also used in the um, implantable training or implantable R&D departments, for example, which are being constructed and which is being having a multi-purpose usage, will be composed by using or will be constructed by using this microprocessor embedded medical application only. So it should be small, it should be lightweight for the portable process, and it should be reliable. That is a first point and very important point according to the biomedical applications. And it should be low power consumption. Why? Because healthcare devices and healthcare equipments will be used for long time process. We can't predict the patient's condition according to the time requirement. So it should be low power consumption and should be in low cost. These are the vital points for using the microprocessor in embedded biomedical application widely to develop the healthcare units as well as the body implants. Body implants means a part which can be replaced in a human body by using the mechanical and electrical and electronic components which should not cause any side effects to the immune system, which should be accepted by the immune system, is known as implant. So implant material microprocessor is being considered as a basic structure of implant material to develop a component to design an implant. This microprocessor is being widely used, and that's all. Thank you. I think I have been provided and I have been explained the vital use of microprocessor and explanation of internal architecture of 8086 as well as the application of 8086 in biomedical domain.